Today we're going to look at how to factor out common monomials. So we're going to begin with reviewing what factors are. So our first thing we want to do is just list all possible factors of 18. There's going to be 6 of them. So remember, factors are things that multiply together to get that number. So things that multiply to get 18, there's 1 and 18, there's 2 and 9, and then there's 3 and 6. So these are all 6 possible factors of 18. Now let's write 18 as a product of prime factors. So if we look at 18 and we break 18 down, we know that 18 is the same as 2 times 9. And then the 9 is the same as 3 times 3. Well, 3 times 3 is 3 squared, so we can rewrite 18 as 2 times 3 squared. Let's list the 4 different prime factors of the monomial 6x squared y. So there's 4 different factors. First of all, 6 breaks down in 2 and 3, and then there's the x, and then there is the y. So these are the factors of 6x squared y. All right, let's find the product of the factors 2x and 4x plus 3. So to multiply 2x and 4x plus 3, we have to distribute. So the 2x and the 4 times the 4x becomes 8x squared, and then the 2x times the 3 becomes 6x. All right, let's list the common factors of 8x squared and 6x. So the common factors that we have 2 as a common factor, and we have x as a common factor. All right, so factoring is a process of determining individual factors of a product. So factoring is kind of like undoing whenever we distribute something. So to start on factoring, you always want to look for greatest common factors of the different terms. So if we have the number 108, the first thing we want to do is to rewrite 108 in factors, right? So we want to factor out 108 as much as possible. If you like to do factor trees, that's probably one easy way to rewrite numbers as factors, is to just do a little number tree. So 108, the factors of 108 factor out to 2 times 2 times 3 times 3 times 3. And then 72, the factors of that are 2 times 2 times 2 times 3 times 3. So we want common factors. Okay, so here's one common, we have one pair here, and then here's another pair, and here's another pair, and then here's another pair. So our greatest common factor is going to be 2 for this pair, times 2 for this pair, times 3 for this pair, times 3 for this pair. So 2 times 2 times 3 times 3, and we get 36. So the greatest common factor of 108 and 72 is 36. Now let's look at 15x. So if we were to break 15x up into factors, it would be 3 times 5 times x. And then 42x squared y would be 2 times 3 times 7 times x times x. That gives us the x squared times y. So if we're looking for common factors between these two things, let's see, we have a 3 that's shared, and we have an x that's shared. So that means that our greatest common factor is a 3 times an x, and 3 times x is 3x. So our greatest common factor of 15x and 42x squared y is going to be 3x. So the greatest common factor of a polynomial is the product of all the factors that are shared by every term of that polynomial. So if two numbers have only the greatest common factor of 1, we say that they are relatively prime. So let's look at 8x squared minus 16. So 8x squared, if we were to look at that as factors, would be 2 times 2 times 2 times x times x. And then 16 would be 2 times 2 times 2 times 2. So we're looking for things that they share. So it looks like they share a 2, a 2, and a 2, which is 8, right? So here's a 2 for this sharing. Here's another 2 for this one. And then here's a 2 for this one. So 2 times 2 times 2 becomes 8. So the greatest common factor of 8x squared and 16 is 8. So now that we know what our greatest common factor is, we're going to factor out 8 from each term. So we're going to take an 8 away from this x squared, and we're going to take an 8, factor out an 8 from the 16. Well, 16 is 8 times 2, so when we factor out that 8, we're going to be left with just that 2. When we factor out the 8 from 8x squared, well, we're going to be left with just 8x squared. So notice how this has just undone a distribution, because 8 times x squared is 8x squared. And 8 times negative 2 is negative 16. So anytime you factor anything, your answer should always be able to take you back to the beginning. All right, so factoring common monomials from a polynomial, the first thing you do is find the greatest common factor, and you're going to divide that greatest common factor out of each term. So you're going to reverse the distributed property. Step 3 is you write the factorization as the greatest common factor times the sum of the quotient. And then check your solution by multiplying those two factors and making sure that you go back to your original question. So let's look at an example. Let's factor 42a cubed plus 14a. So step 1 is to identify the greatest common factor. So we're going to rewrite 42a cubed as its factor. So 42 breaks into 2 times 3 times 7, and a cubed is a times a times a. And then 14a breaks down to 2 times 7 times a. Now we're going to identify the common factors. So they have a 2 in common, and a 7 in common, and an a in common. So 2 times 7 times a is our greatest common factor, which is 14a. So now we know what we want to factor out. We know what the greatest common factor is. So we're going to divide that from every term, right? So 42a cubed divided by 14a leaves us 3a squared. And 14a divided by 14a leaves us 1. So when we factor out the 14a, so we divide both of them by 14a, we're left with 3a squared plus 1. Next example, we're going to factor out this. This is a trinomial, and we're going to look for our greatest common factor. So the greatest common factor of 36, 9, and 27 is going to be 9, because 9 can go into all of those. And then the greatest common factor, the next term in our greatest common factor is going to be x, because every term has at least one x that we can divide by. And then the next part of our greatest common factor is going to be y, because every term has at least one y that we can divide into. So our greatest common factor is 9xy. So now we take that greatest common factor and we divide each term by that greatest common factor. So when we do 36x squared y and we factor out a 9xy, we are left with 4x, because 9xy times 4x gives us 36x squared y. And then when we take 9xy cubed and we factor out that 9xy, we have to be left with y squared, so that way we can get back to that 9xy cubed. And then if we factor out a 9xy from 27xy, we're left with 3, so that way we can get 9xy times 3 and get back to the 27xy. So when we take this 9xy and we factor it out, we're left with 4x, we're left with plus y squared, and we're left with minus 3. So when we want to factor 51x cubed plus 26y, well, 51 and 26, those are relatively prime. They don't share any factors, and x cubed and y also are relatively prime. So our greatest common factor is 1, and so they're relatively prime. Then that means that the polynomial is prime, and it's not going to factor. So a polynomial can also contain a common binomial factor. So we've been factoring out monomial factors, but we can also factor out a binomial factor if every single term has one. So for example, if we have 3 parentheses x plus y minus y parentheses x plus y, there are 2 terms here. This is our first term, and this is our second term. So notice that both terms have an x plus y. So we can factor out that x plus y, and when we do, we're left with 3 minus y. So let's factor x parentheses x plus 1 plus 2 parentheses x plus 1. So notice that there are 2 terms here. This is our first term, and this is our second term. So each term has an x plus 1 that we can factor out. And when we factor out the x plus 1, we're left with x for this term, and then we're left with 2 for this term. All right, that's all for this one, so go ahead and try some problems on your own.